Hi everyone, I hope you are well. I just wanted to record a short video just to give you an overview of the computer practicals and a very quick introduction to MATLAB. So with the computer practicals, these are going to mirror the lectures. So the practical each week will mirror what you do in that week. So for example, in week 2, we're talking all about mean sea level. So the week 2 practical is going to be about mean sea level. And it's really hard to do these practicals because some of you have MATLAB experience, some of you don't. But I've really tried to prepare them in such a way that no matter what your MATLAB background is, you should be able to do this and hopefully you should be able to enjoy it. But what I really wanted to do was give you real practical experience of using actual sea level data. So we're going to use data from different tide gauges from all around the world: Australia, China, Vietnam, America, the UK. And we're going to, get you to load in data of different formats and do some, simple but quite nice analysis types. So in practical 1, it's just a really kind of more simple introduction to MATLAB. We're going to plot and analyze a year's worth of tide gauge data from the US NOAA, the National Oceanography and Atmospheric Administration tide gauge at Battery Point, shown down here, near from where the ferry goes to Staten Island. And we're going to focus on the year 2012 because that's when Hurricane Sandy generated a very large storm surge here on the 30th of October. We're also going to look at the meteorological conditions during the storm. So we'll do some plots that look like this, where we have our tides are in red, the water levels in blue. You can see a really big storm surge of up to 3 meters here, which flooded quite a bit of Manhattan, some of the metro stations and things. And then we're going to be plotting the meteorological conditions. So this plot here shows low pressure of the hurricane and the winds around it. In practical 2, we're going to focus on mean sea level, and we're going to look at Fremantle, the longest tide gauge record in the southern hemisphere, and we're going to download data from the Permanent Service for Mean Sea Level. And we're going to separate the mean sea level into 3 component parts: kind of seasonal cycle, a year-to-year variability, an interannual cycle, and then a longer-term trend. So, for example, here you can see the total mean sea level at the top. It's got a seasonal component, an interannual component, which we'll see relates very closely to ENSO, and then a linear trend. And we'll look at each of those components in more detail. For example, here's the seasonal cycle here. In practical 3, we're going to focus on the tidal component of sea level, and we're going to load in and analyse sea level data from 5 tide gauges along the coast of China and Vietnam. We're going to download data from the University of Hawaii from a NetCDF format, which is very common in climate studies. We're going to do a tidal analysis using the U-tide, and then we're going to be able to predict the tide for a different period. We're going to examine the tidal constituents, calculate the form and the range of the tides, whether it's diurnal, semi-diurnal. In practical 4, we're going to look at extreme sea levels at Portsmouth. We're going to extract the largest sea levels every year, and then we're going to undertake an extreme value analysis to calculate return period. So what a 1 in 100 year event is, an event that we'd only expect to be reached once every 100 years. And then we're going to use sea level projections from the UK Climate Programme to consider how a 1 in 100 year event might change with sea level rise. And then Ian will take over from me. So in practical 5, you are going to examine beach dynamics at Hemsbury's Head, and that's going to mirror the kind of coastal response one. So you're going to use water level and wave data from the Coastal Channel Observatory and BODC to look at littoral drift. And I'll let Ian explain this. Now, Ian developed a really nice set of tools called Coastal Tools, and you can do this using Coastal Tools or your own code. And then in week 6, there's 2 options as far as I'm aware from Ian. So you're going to use Coastal Tools to look at design conditions for the seawall at Hemsbury's Head. So you're going to do kind of overtopping calculations. Or you can look at the impact of a dredge in Southampton Water. And again, I will let Ian explain this to you. And here you could use a model called ASMeter from within MATLAB. Okay, so let's just quickly talk about MATLAB. For those of you who are very familiar with MATLAB, you don't have to listen to this, but MATLAB is a high-level programming kind of interactive environment, especially based around kind of matrix numerics. It's really fantastic at data analysis and visualization. and it's really nice. You can automate, write algorithms, kind of automate very, you can load in data for one site, automate it to load in data for 1,000 sites around the world and do that analysis. Now, MATLAB stands for Matrix Laboratory. It's got about 3 million users worldwide. It's developed by a company called MathWorks. It's developed by a guy called Clive Moller, who was originally an academic and was a bit frustrated with the programming languages at the time. So it's developed in the 1970s, so that students wouldn't have to learn a more complicated language called Fortran, but it's come a long way since then. So with MATLAB, there's two main softwares. There's MATLAB itself, which is more about performing mathematical calculations, visualization, writing new software, or there's Simulink. Now, I never really use Simulink, but Simulink is, for example, used in kind of sort of modeling applications. And across these two, there's 80 specialized toolboxes. So there's a toolbox for image processing, a toolbox for curve fitting, a toolbox for finances. So MATLAB and Simulink kind of sit here in the middle, and then around them is all of these tools. Sorry, I don't know why my screen has crashed. Let me just load that up again and continue talking. Sorry about that, but just take a second to load up. So while we're waiting, I'll just show you MATLAB itself. Oh, hold on, I think we're loading up again. I installed some new software on my machine and it seems to be crashing PowerPoint. Okay, it's a bit frustrating that MATLAB have done this because often you have to pay for these extra add-on packages. But if you go into MATLAB and type version, you'll see you have MATLAB Simulink, and then you can see which particular packages you have here. I think within this toolbox, the only one we'll be using is, in fact, I don't think we'll use any of the. It might just be the statistical toolbox that we utilize. Now, with programming languages, you normally have very, very fast programming languages, and they're up here. They're low level. So essentially, a computer just works with binary switches that turn 1 and 0 on. They're incredibly fast, but only experts understand that. Down at the other end, you have often a slow interface, but it's very high level. So at this end, it could just be speaking to the computer and it does what you want. Now, traditional programming languages like Fortran and C++ are up here. They're very high, but they're quite low level. They're quite complex commands that take a long time to learn. Visual Basic is very easy to understand, comes with Microsoft, but it's quite slow. MATLAB was aimed to be sitting up here where it's quite easy to program, it's quite intuitive. So if you want a new figure, you just type the word figure. If you want to load in data, you type the word load. If you wanted to add an X label, you type X label. It's quite easy to use, but it's quite fast as well. So MATLAB is relatively easy to program. It's quite powerful. It's much more powerful than Excel, for example. It's got really good plotting. It's a huge range of plotting functions. It's got very good support and help, and there's a forum that you can go on and ask for help. And it's got a fantastic user community. So there's lots of third-party products. So we're going to use a third-party product called UTide, for example, to do your... So that's been produced by someone outside, but they've shared it through this kind of MATLAB Central website. So often if there's something you want to do, the first place before you write it is to look at MATLAB Central and say, well, do I need to create it? Someone else might have done it for me. Sorry, I don't know why my Teams messages are coming up. Okay, so MATLAB takes a lot of time to learn, but you just have to practice, and over time you'll get easier. One of the disadvantages is it's not free, like Python, Octave and R, so you do have to pay for it, although it's obviously through the university you don't. It's quite slow with very, very large data sets. It can handle big data sets, but if it's huge data sets, it's a bit slow. I find it annoying that you have to pay for these extra toolboxes. Luckily, through the university, we get them all for free. And the statistics in MATLAB is a little tiny bit limited. If you want to do really good statistics, it's probably better to use R. But having said that, I've used MATLAB for 20 years and love it. So when you open MATLAB, you have this window here. And the first thing you need to do is click into a directory. So you always work from a directory. So here you can see they're working from a particular directory. And in this window, you can see what files are in that directory. You then have your main command window where you type in commands. So X is 4, Y is 2, Z is X plus Y. Here you can see your workspaces. Now, you don't necessarily need to keep them in this format. You can move these windows around how you like it. But you could double click on X, for example, and you can open your X window up. And you can see your command history, the commands you've typed. I tend to, rather than work in the commando, create a new script. So you can click on the new script and create that. So MATLAB is really good at handling numbers or matrices. So matrices or an array might look like this. So you might have, this is a 2 by 3. It's got 2 rows and 3 columns. So it could be numbers 1, 2, 3. This could be sea level. It could be temperature. Month 1, temperature's 20 degrees. Month 2, temperature's 30 degrees. Month 3, temperature's 76 degrees. So this is a matrix, a 2 by 2. This is a row vector. This is a column vector. And essentially, you think of it a bit like Excel. You've got rows and columns, so MATLAB handles numbers in exactly the same way. Now, in MATLAB, what is really useful is indexing. So let's say I wanted this number 8.8 here. In Excel, that would be B11. MATLAB works for the same ways. You have a circular bracket. So let's say we have a matrix as 1, 2, 3, 20, 35, and 17. So row 1, row 2, columns 1, column 2, columns 3. What you do is you call the matrix A. You have circular brackets. The first number is the rows going from the top to the bottom. The next number is the columns going from left to right. So row 1, column 1 would give you the number 1. Row 2, column 3 would give you the number 76. And this is just a really nice way of manipulating data. So you can have one-dimensional data, which is either a row, for example, water depth, or you can have two-dimensional data, which might be temperature. So this might be temperature at the surface, temperature 10 meters down, temperature 20 meters down. This could be January, February, March. Something like that. So you'd have a depth matrix, a row matrix, and a temperature matrix. You can also have three-dimensional data. So this might be different years, the data in 2025, 2026, 2027, 28, 2029, for example. And indexing works in the same way. Number 5 is the row, so it'd be 1, 2, 3, 4, 5, that'd be 11. Column 3, you go along to 17, and 5 is the third dimension, so it would be not the first year, not the second, not the third, not the fourth, it would be this year, so that would be number 16. So you can index in 3 dimensions, even 4 dimensions, even 5 dimensions. Now in MATLAB, it's like learning a language. There is grammar, and this is to do with the brackets, and this just takes time. You just have to practice this, but when you enter numbers, you use a square brackets. If you enter numbers as a column, it would be a row. If you use a semicolon, it would be a column. So this would give you a row, that would give you a column. You can also cheat as well. Rather than writing numbers 1 to 5, you could say I want to go from 1 to 5 at intervals of 1. Or you could say I want to go from 1 to 5 at intervals of 2, that would be 1, 3, 5. Whenever you enter numbers, it's square brackets. Whenever you enter text or strings, you have a single quote. You can have these funny brackets here, which is a cell array where you can enter numbers and strings together. Or you can use what's a structured array, which is a dot, where again you can enter strings and numbers together. But I tend to just focus on these. Within the practicals, we won't be doing the second part. What's really powerful about MATLAB is there's lots of functions. And it's a bit like in Excel. If you were to click on a cell down here, you could write equals average B2 to B17, and that would give you the average of the temperature. So let's say we had this column of data going from 23.2, 23.1, all the way to 7.9. I haven't typed in all the numbers here. In MATLAB, the format is exactly the same. You have a square brackets, which is the output. So my output is going to be a variable called m. You then have the equal signs. You have the function name, mean, and then you have the input. So input here, I would put in this x column of temperature, and I would get out an m. Now, the nice thing with MATLAB is all functions are the same. So once you use one function, you can use any function. So there's another function called sum. So here you might take the sum of 3 different matrices. So these are all inputs, and it might give you 4 outputs. So you always have the name of the function, the inputs and the outputs. And throughout the course, we'll be using a whole range of different functions. But now you know how to call them. There shouldn't be a single function in MATLAB that you don't know how to use. So for example, here's a min function. And often it's easy in MATLAB. If you want a mean, it's the word mean. If you want a max, it's the word max. If you want a sum, it's the word sum. If you want a standard deviation, it's STD. You know, it's quite straightforward. Okay, so let's just have a very quick look at MATLAB. So here is the MATLAB window. Okay, so I've got mine set up a little bit differently, but first of all, you always have a folder. So you can click on here and you can navigate to a folder somewhere in your computer. I'm going to go into Practical 1, which I created previously. So here you can see the folders that I've got into Practical 1. But essentially, MATLAB is a glorified calculator. So you can enter X is 1, Y is 2, and Z is X plus Y. Now notice if I put a semicolon, it doesn't write the results to the screen. If I do put a semicolon, it does. So in a sense, it's just so here I've created 3 variables, and they're one-dimensional variables. And you can just double click on an X and see what it looks like. If I wanted to enter more numbers, I could go 1, 2, 3, 4, 5. If I put a semicolon in between it, it would write it as a column vector. And so there's just a sort of very quick overview of MATLAB. Now there's lots of things going on here that you'll work over time, and we'll look at some of those. But rather than, let's say for example, I wanted to enter a string, I could put my name. It's always quotes. If you want a new figure, it's figure. And we could plot A. So you can see it's quite straightforward, and you can zoom in, you can change the colors very easily, and we'll do all of this in the practicals here. Now, rather than working from the command line, I always create a new script, and it brings up this script editor. So here we could say A is we want to go from 1 at intervals of 1 to 10. B is the sign of A. We could bring up a new figure, and we could plot A versus B as a red line, and we could run it. So I always, we need to give this a name. Let's just call it test. I've already got a test. Let's call it test 2. We can run that, and you can see it's brought up a sine curve. It'll be a bit better if we go intervals of 0.1. It'll be smoother. There you can see. I plotted it as a line, but we can also plot it as circles. So that's just a very, very quick overview for MATLAB, but most of the time we're going to be using the editor. The advantage of an editor is then you can just run your code all in one go, and it saves it as well. So I'll just bring up an example. This is the control 1 that you're going to be creating yourself in Practical 1. And you can see we've got all the commodes in there, and it produces a nice figure of where our first tide gauge site is in New York. Again, you can zoom in, you can save this figure. There's lots of things you can do. So yeah, I really hope you do the practicals. This year's a bit of a test because this is all new, but let me know what works, what doesn't work, and yeah, but I hope you enjoy it. Okay, all the best.